Welcome to MindTier Learning, where GCSE Geography is made simple. This presentation is designed to help you navigate the key strategies and tips for effective study and revision. Whether you're just starting your GCSE journey or looking to improve your current habits, we'll cover practical methods to make your learning more efficient and less stressful. Let's get started on making your revision journey straightforward and successful. Welcome to today's lesson on marine erosion processes. In this lesson, we are going to look at how the power of the sea shapes our coastlines. When we look at cliffs, caves, arches, stacks, wave-cut platforms, or rapidly retreating coastlines, we are seeing the results of erosion over time. Marine erosion means the wearing away and removal of rock by the sea. The sea is incredibly powerful. Waves can crash into cliffs again and again, forcing air into cracks, throwing pebbles against rock, dissolving certain minerals, and moving broken material around. Today, we will focus on 4 key processes: hydraulic action, abrasion, attrition, and solution. We will also look at why some cliffs erode quickly while others resist erosion for much longer. The big question for today is, how does the sea break down rock, and why do some coastlines erode faster than others? Let's begin with today's learning objectives. By the end of this lesson, you should be able to do 3 things. First, you should be able to explain the 4 main processes of marine erosion. These are hydraulic action, abrasion, attrition, and solution. Each process breaks down rock or sediment in a different way. Second, you should be able to analyze how compressed air drives hydraulic action. Hydraulic action is often misunderstood. It is not just water hitting a cliff. It is also the force of air being trapped and compressed inside cracks. Third, you should be able to evaluate the role of rock lithology in determining erosion rates. Lithology means the physical characteristics of rock, such as hardness, structure, and composition. Some rocks are hard and resistant. Others are soft, weak, or heavily jointed, making them easier to erode. So today's lesson is about both process and resistance. The sea provides the energy, but the type of rock affects how quickly erosion happens. Before we go further, let's go through the key vocabulary. The first term is hydraulic action. Hydraulic action happens when water crashes against rocks and compresses air into cracks. The pressure forces cracks open and eventually breaks the rock apart. The second term is abrasion. Abrasion is the sandpaper effect. It happens when pebbles, sand, and other sediment are picked up by waves and flung against the cliff face, scraping and wearing it away. The third term is attrition. Attrition happens when rocks in the sea collide with each other. They break into smaller, smoother, and rounder pieces. The fourth term is lithology. Lithology means the physical characteristics of a rock, such as its hardness, composition, grain size, joints, and faults. These words are essential because they allow us to explain not just that erosion happens, but how and why it happens. Before the sea even touches a cliff, other forces may already be weakening it. One important process is weathering. Weathering is the breakdown of rock in place. This means the rock is weakened, but not necessarily removed. For example, freeze-thaw weathering happens when water enters cracks in the rock, freezes, expands, and forces the cracks wider. Another important process is mass movement. Mass movement is when material moves downslope under the force of gravity. This can include rockfalls, landslides, rotational slumps, mud flows, and soil creep. Weathering weakens cliffs from above. Mass movement causes sections of cliff to fall or slide. Erosion is different. Erosion is the active removal of rock by the sea's energy. So the coast is shaped by a combination of weathering, mass movement, and marine erosion. But today our focus is on marine erosion. Let's check your knowledge of mass movement. The question is, which type of mass movement involves a saturated tongue of debris moving downhill rapidly? Is it 1. Rockfall, 2. Rotational slump, 3. Mudflow, 4. Soil creep? Take a moment to think. The key clue is the word saturated. Saturated means full of water. When soil and debris become full of water, they can flow downhill quickly, almost like a thick liquid. The correct answer is 3. Mudflow. A mudflow happens when saturated soil, sediment, and debris move downhill quickly. This usually happens after heavy rainfall, when the ground becomes waterlogged and loses strength. Rockfall is when pieces of rock fall from a cliff, often after weathering. Rotational slump is when a section of cliff moves downwards along a curved slip plane. Soil creep is very slow downhill movement of soil. Mud flow is the rapid movement of saturated debris, which is why it matches the question. This recap is useful because mass movement can expose fresh cliff faces to wave attack, making marine erosion even more effective. Now let's focus on the power of waves. The slide asks us to imagine a 3,000-ton wall of water hitting a cliff every few seconds. That gives us a sense of how much force waves can have, especially during storms. But one of the most interesting ideas is that water alone is not always the only thing causing the damage. Often, the most explosive destruction comes from air trapped inside cracks in the rock. When a wave crashes into a cliff, water is forced into cracks and joints. Air already inside those cracks becomes trapped and compressed. Then, when the wave retreats, the pressure is suddenly released. This repeated compression and release puts stress on the rock. Over time, the cracks widen and pieces of rock break away. This is the process we call hydraulic action. Now let's look closely at hydraulic action. Hydraulic action happens when waves hit a crack in a cliff. The water traps air inside the crack and compresses it. To the rock, this pressure can act almost like a small explosion inside the crack. When the wave retreats, the air expands suddenly. That expansion weakens the rock from the inside. This process repeats again and again. Each wave forces air in, compresses it, releases it, and weakens the crack. Over time, the crack becomes wider. Eventually, sections of rock break away. The slide notes that this pressure can reach over 100 tons per square meter, which is enough to move massive boulders. Hydraulic action is especially powerful during storms because storm waves have more energy and strike the cliffs with greater force. This process is very important in forming caves, arches, and wave-cut notches. Now let's look at abrasion, also called corrosion. Abrasion happens when waves pick up sand, shingle, pebbles, or larger rocks and throw them against the cliff face. Think of it as the sea using sandpaper. The sediment carried by the waves scrapes, chips, and wears away the rock. Abrasion is especially effective at the base of cliffs, where waves repeatedly strike between the high tide and low tide marks. Over time, this scouring action can help carve out a wave-cut notch. A wave-cut notch is a dent or hollow at the base of a cliff. As the notch deepens, the cliff above becomes unsupported and may collapse. Abrasion is most active during storms because waves have enough energy to carry larger rocks and hurl them with greater force. So, while hydraulic action uses pressure and trapped air, abrasion uses sediment as a tool to wear away the coast. Now let's look at two more erosion processes, solution and attrition. First, solution, also called corrosion. Solution happens when chemicals in seawater dissolve certain rock types. Seawater is slightly acidic, so it can dissolve rocks such as limestone and chalk. This means the rock is gradually eaten away by chemical action. Solution is especially important on coastlines with rocks that are more chemically reactive. Now let's look at attrition. Attrition is slightly different because it does not directly erode the cliff. Instead, it erodes the load being carried by the sea. Pebbles and rocks in the surf collide with each other. As they smash together, they become smaller, smoother, and rounder. This is why beach pebbles are often rounded rather than sharp. So remember, solution dissolves rock chemically. Attrition wears down the sediment itself. Now let's match the erosion processes with their definitions. The processes are 1. Attrition 2. Solution 3. Hydraulic action 4. Abrasion. The definitions are A. Rocks hitting each other and becoming rounded. B. Rocks hurling against the cliff like sandpaper. C. Air being compressed into cracks by waves. D. Seawater dissolving chemicals in the rock. Take a moment to match them. Be careful with abrasion and attrition. Abrasion is rocks hitting the cliff. Attrition is rocks hitting each other. Let's go through the answers. Attrition matches with A. Rocks hitting each other and becoming rounded. Solution matches with D. Seawater dissolving chemicals in the rock. Hydraulic action matches with C. Air being compressed into cracks by waves. Abrasion matches with B. Rocks hurling against the cliff like sandpaper. A simple way to remember the four processes is: hydraulic action is pressure. Abrasion is scraping. Attrition is collision. Solution is dissolving. If you can explain those four clearly, you will be able to answer many coastal erosion questions well. Now let's look at why some coasts erode faster than others. The key word here is lithology. Lithology means the physical makeup of the rock. Not all cliffs are made from the same material. Some rocks are hard and resistant. For example, granite is a hard igneous rock. It has an interlocking crystalline structure, which makes it strong and resistant to erosion. Other rocks are much softer. For example, clay is weak and easily eroded, especially when it becomes saturated with water. Lithology also includes the number of joints, cracks, and faults in a rock. A cliff with many joints and faults may erode faster because hydraulic action can exploit those weaknesses. Water and air can enter cracks, pressure builds up, and the rock is forced apart. So erosion rate depends on both wave energy and rock characteristics. A hard, massive rock with few joints will usually erode slowly. A soft, weak, or heavily jointed rock will usually erode quickly. Now let's test that idea. The statement says, an igneous rock like granite will erode faster than a sedimentary rock like sandstone. Is that true or false? Take a moment to think. Granite is an igneous rock with interlocking crystals. Sandstone is a sedimentary rock made from compacted grains of sand. Which one is usually more resistant? Which one is more likely to have layers or weaknesses that waves can exploit? Think about rock hardness, structure, and resistance. The statement is false. Granite will not usually erode faster than sandstone. The correct explanation is, granite is much harder and more resistant because of its interlocking crystalline structure. This makes granite difficult for waves to break down. Sandstone can be resistant in some cases, but it is usually less resistant than granite and may be more affected by joints, bedding planes, and weathering. Option B is incorrect because being formed in water does not automatically make sandstone more resistant to marine erosion. So the key point is, hard, crystalline rocks such as granite usually erode more slowly than softer or more layered sedimentary rocks. The correct answer is A. Granite is much harder and more resistant due to its interlocking crystalline structure. This is an important idea for explaining uneven coastlines. Where hard rocks are found, erosion is slower and headlands may form. Where softer rocks are found, erosion is faster and bays or rapidly retreating cliffs may form. However, rock type is not the only factor. Erosion also depends on wave energy, fetch, storm frequency, beach width, cliff height, rock structure, and human management. A strong GCSE answer should combine physical process and geology. For example, a granite coastline is likely to erode slowly because granite is hard and resistant. A clay coastline is likely to erode quickly because clay is weak and can become saturated. If powerful destructive waves attack the clay coast, erosion will be even faster. Now let's apply today's learning to the future. The question is, if global warming leads to more frequent, intense storms, which erosion process will accelerate most, and which coastline lithology is most at risk? Let's break this down. More intense storms mean more powerful waves. More powerful waves increase hydraulic action because waves hit the cliff with greater pressure and force more air into cracks. They also increase abrasion because waves have enough energy to pick up and throw larger rocks and pebbles against the cliff. So hydraulic action and abrasion are likely to accelerate most. Now think about lithology. Which coastlines are most at risk? Soft rock environments are most vulnerable. For example, coastlines made from clay, sand, or weak sedimentary rocks are likely to erode quickly. The Holderness Coast is a good example because it is made of soft boulder clay and is exposed to powerful waves from the North Sea. Hard crystalline rocks, such as granite, will usually remain more stable because they are more resistant. So climate change could increase erosion rates, especially where powerful waves attack soft or heavily jointed rock. You might have said that hydraulic action and abrasion rely on wave energy. That is correct. If storm waves become more frequent and powerful, these processes are likely to become more intense. You might have said that soft rock environments like the Holderness Coast are most at risk. That is also correct. Soft rocks such as clay are weak, easily saturated, and more vulnerable to collapse and erosion. You might have said that increased storm frequency means waves attack cliffs more often. That is another strong point. You might also have said that crystalline rocks remain more stable than sedimentary rocks. A strong GCSE answer might say, if storms become more frequent and intense, hydraulic action and abrasion will accelerate because storm waves have more energy. Hydraulic action will force air into cracks with greater pressure, while abrasion will throw larger sediment against cliff faces. Soft rock coastlines, such as the Holderness Coast, are most at risk because clay and weak sedimentary rocks erode quickly. Hard crystalline rocks, such as granite, are more resistant and will erode more slowly. That answer is strong because it links climate change, wave energy, erosion processes, and lithology. Let's finish by summarizing today's lesson. Marine erosion is the wearing away and removal of rock by the sea. The four main processes are hydraulic action, abrasion, solution, and attrition. Hydraulic action happens when waves compress air into cracks in a cliff, weakening and breaking the rock apart. Abrasion happens when waves throw sand, pebbles, and rocks against the cliff, scraping it away like sandpaper. Solution happens when slightly acidic seawater dissolves rocks, such as limestone and chalk. Attrition happens when rocks in the sea collide with each other and become smaller, smoother, and rounder. We also looked at lithology. Lithology means the physical characteristics of rock, such as hardness, composition, and structure. Hard rocks, such as granite, erode slowly. Soft rocks, such as clay, erode quickly. Rocks with many joints and faults erode faster because hydraulic action can exploit those weaknesses. The biggest takeaway from today is this. The rate of coastal erosion depends on both the power of the sea and the resistance of the rock. Before we wrap up, I just want to remind you to like and subscribe to our channel. Your support helps us continue creating valuable content and keeps you updated with our latest videos. Thanks for watching.